Good afternoon, students. So now we will continue with our next sessions of design and analysis of algorithms laboratory. So we have finished 7 programs so far. Now we will see what is the 8th program. So the 8th program is to find the minimum cost spanning tree of a given undirected graph using Kruskal's algorithm and implement the program in Java language. So, before going to the program, what is minimum cost spanning tree? We all know that a spanning tree is nothing but connected graph and it will be acyclic. There should be no acyclic. There should be no cycles. Okay. So, a spanning tree of a connected graph is a connected acyclic subgraph that contains all the vertices of the graph. That is, it should contain all the vertices, but I have to remove the edges. So a minimum spanning tree of a weighted connected graph is the spanning tree of the smallest weight, where the weight of the tree is defined as the sum of the weights of all edges. Okay, so we already know about minimum cost spanning tree. So this was the example that we have studied for Kruskal's algorithm. So Kruskal's algorithm will employ greedy technique, okay, to find the minimum spanning tree and yield the optimal solution. So what was the procedure? So the procedure was, I take from the source edge, that is, I first take A, B, and then we will try out all possible solution. That is, first of all, I write down all the edges. See here, we have written all the edges B, C, E, F, and these are written in such a way that they are sorted list of edges. That is, the low edge with the least weight will be written first and it goes in the increasing order. Then consider each and every edge, include it only if it is not causing a cycle. If it is causing a cycle, we don't include that particular edge. This was the problem, and this is the algorithm. So input is a weighted graph, then output is a set of edges composing of minimum spanning tree of G. Okay, and then I have a ET, initialize the tree's edges and its size. ET is edge and encounter is 0. That is the size. Then initialize the number of processed edges. That is how many edges I am going to process. So while E counter is nothing but the weight of that particular edge. Suppose I take AB, what is the weight of AB? Initially it will be 0. If encounter is less than B minus 1, that is, except the source node, it is including all the other vertices. What I have to do is increment the value of K, that is the number of edges that I am going to visit. And if I take this new edge and add it to the list of edges, and if it is acyclic, then include it and increment the value of encounter, then return the edge that I have included. This is what is the algorithm doing. So now let us see the execution part of this particular algorithm. So we are creating a class with the name lab 8. So it's public static void main. Now my program layout is ready. So since I'm not typing the program, I just delete everything and copy paste my already existing program. Now we will save the program so that I can get to know if there are any errors. I have saved it and it doesn't show any errors. So we will see what is happening. Okay, so here I have a public class with lab, the name of the class. Then I create an array of parent. Then here it is a method find M, where I am trying to find an edge between two nodes. Okay, that is, if I am considering B vertex and A is the source vertex, I am trying to find if I can include an edge from A to B. To do that, I have this method. Then I have one more method called union, because in the algorithm we saw that I say ET is equal to E of IK union ET. Correct? I am including that edge to the set of edges. To do that, I have this function. And then, so this is one more method, KRKL, which is nothing but Kruskal's, the actual implementation. Then I have the u is equal to 0, v is equal to 0. Then I'm trying to find out an edge from u to v. These are all the other required or supporting variables. While k is less than or less than n minus 1, initially k is 0, k should be less than n minus 1, then minimum is infinity. So I'm trying to write a cost adjacency or trying to read the cost adjacency matrix. Whenever minimum is 99 means it is infinity. I can't write infinity, so I'm giving some larger number. So 2 loops, and I check each and every edge a of I and j. I take one particular value in the matrix and I'm checking if it is minimum, and I'm also checking that I is not equal to j, which means to say that there will be no edge from 2 to 2, correct? Or if I take a vertex b, there will be no path from vertex b to b. Just to avoid that, I am using this condition. Then I update my minimum. After updating the minimum, since it is less than minimum, this particular value is less than minimum, I update the minimum value to the new value. Then u will be I and v will be j. That is, I am creating a path from I to j. That is, if this is a of, this is suppose 2 and this is suppose 3, I have a edge from a 2 to 3. After I know the value of I and j, I call the function find, and then I call the function union. So here we have understood what find does and what union does. So I know the value of I and j. I am sending it. Okay. Find u. I am sending find u. That is, I am trying to find the parent of u. Suppose I am trying finding out a path from b to c. I am trying out to find what is the parent of b. That is, whether b is connected to the source node a. To check that, I have this, and then I am, if at all it has a parent, I'm trying to find a parent, and then I am including that particular edge into the list of minimum spanning tree edges. So this is the program. And coming to the main part, void main. Here I am entering the number of vertices in the graph. Then I am entering a weighted matrix. After that, I am calling the Kruskal function with the matrix A and the number of nodes n. Within Kruskal's, I will call find and union. That is, finding the parent to which it is connected, and also if at all the conditions are satisfied. If I see here again, I am checking if I is not equal to j, then only include that particular edge into the list of minimum spanning tree edges. So after understanding the program, we will see the execution part of the program. So it is asking the number of vertices in the graph. So number of vertices, let it be 4. And now they are asking me to enter the weighted matrix. Based on the graph, I can write the weighted matrix. Okay, you can write down a graph and try to execute it. What you can do while executing is write down a graph, write the weighted matrix which you already know. After writing the weighted matrix, it also either try doing the problem manually. So it is finding all the minimum path. There is a path from 1 to 3, 2 to 4, and which is 0, 2 to 5 is 5. Okay. So the cost of minimum spanning tree is 5. See here, he says that there is a path from, if I say this is node 1, 2, 3, 4, this will be 1, 2, 3, 4. There is a path from 1 to 3. Also, there is a path from 2 to 4. Okay. And also there is a path from 1 to 2. This is the cost. So now we have understood what is, how to implement Kruskal's algorithm.